In this lesson, we're going to look at a couple of application questions dealing with exponential and logarithmic equations. So the first has to do with something we've actually already talked about before, which is interest that is compounded continuously. So notice that we're using this model, A equals P e to the RT. E, of course, is that constant we've been working with. So if $10,000 is invested, that tells me P, principal. The account is earning 4.5% interest, so we're going to use 0.045 as my rate. And in this case, though, this is a little different. We haven't done this yet. We're trying to solve for T. They're asking how long will it take the money to grow to 25,000. So we have used this function before, but we haven't used it in this way. So I'm asking for when the accumulated amount will be $25,000. My principal is $10,000. E to the RT, so R is 0.045. T is my unknown. Now, of course, if I'm going to do this, that looks like a decimal. If I'm going to do this, I want to first get that 10,000 off of the right side. So I'm going to divide each side by 10,000, and that gives me 2.5 on the left if I divide each side by 10,000. And this is e to the 0.045t. Now from here, remember, I'm trying to get t by itself, but I can't get to it because it's an exponent. So I'm going to take the natural log of each side. And when I do that, the left side, nothing happens yet because that would be an ugly decimal that I'm not going to deal with yet. This side, the natural log and the e cancel, and that gives me 0.45t, which means now I can divide each side. So natural log of 2.5 divided by 0.045 equals t. That's the exact answer. We're going to round this to the nearest year. So now I'm going to use my calculator to determine what this value is. And I get a solution of 20.362. In terms of when we round to the nearest year, some would say that's about 20 years, and some would say it's 21 years. And they would say it's 21 years because it happens in the middle of the 20th year, which means you really don't have that money until sometime in the 21st year. So that's why we would round it to 21, even though mathematically, typically we would round that to 20. So we're going to say in about 21 years, we'll have 25,000 in the account if we're earning 4.5% interest. Here's another application question, again, using a logarithm. And this one, they've already written that function for us, and they've told us that energy is what E represents in this question, and that magnitude is what M represents in this question. And so they've given me this function to determine the amount of energy based on the magnitude of an earthquake. So of course we all know that Haiti was hit by a massive 7.0 earthquake back in 2010. So let's talk about what energy was released from that. So I'm going to replace M in the function with 7.0 because that was the magnitude of the earthquake. I'm going to simplify the right side by multiplying those values together, and then of course by adding those values together. So I have log of E equals 15.32. Now I know that I'm trying to find what E is, but I have this log in the way. So of course to get rid of the log, since this is base 10, I'm going to exponentiate each side, so it's 10 to that power. So 10 to the log base 10 makes it just E, which is what I wanted. And then 10 to the 15.32, when I plug that into my calculator, I get a very weird looking answer. And so I want to talk about what that answer means, because my calculator says 2.0892996, etc., times 10 to the 15th. Quite often, now this is a great answer, I'm going to leave mine like this, but quite often calculators don't have the 10 to the 15th. They'll say 2.0892996, etc., E15. And this is what that means. So if you end up with an answer like this, it's giving you the solution in scientific notation, meaning that I would actually, if I wanted the real answer, I would take this decimal and I would move it 15 places to the right. So that would be a very, very, very large number. That would be a massive amount of energy that was released in that earthquake. And of course, I would label this in joules. But again, if this is the answer you're getting in your calculator, you haven't done anything wrong, but please don't write it like this because that is not what we're looking for. So that's scientific notation, which means times 10 to the 15th. Here's one for you to try on your own, so give it a shot, then press play to check your work. So this one says determine how long it will take 10,000, so that means that's principal, compounded continuously. So again, we're going to be using that PERT equation at 8% to double. So I know I have 10,000 and I want my accumulated amount to be double that, so it's going to be 20,000 equals 10,000 e to the 0.08, which is my rate, t. I'm going to divide each side by 10,000, which gives me 2. Then I'm going to take the natural log of each side. And when I do that, the left side stays natural log of 2, but the right side makes that exponent now just a regular old number. And now I can divide each side by 0.08. And then again, I'm going to use my calculator. I'm rounding to the nearest year. This gives me about 8.664, etc. for t. And of course, if I'm rounding to the nearest year, I would say about 9 years. So over 8, so about 9 years.